All right, the next kind of problem. You don't need to have the normal curve memorized. 34%, 34%, 13.5%, 2.5%. As I've said many times, you can find slightly more accurate standard curves. And in fact, your z-score sheet is a standard curve, normal curve, more accurate. But these numbers are accurate enough. All right, a certain tire has a mean tire life of 52,000 miles, a standard deviation of 4,000 miles. Tires are made of rubber. Rubber is not absolutely 100% consistent. Plus, the manufacturing process could go less stringent or more stringent as far as needing to make it perfect. What you see right here is the same every time. What is different is this. We put the mean of this problem underneath it, 52,000. Add 4,000, 56 and 60. Add 4,000, take away 4,000. And take away 4,000. And now if you will remember the kinds of questions that we had, the kinds of questions are this. They might like say, what percent of tires fail before 48,000 miles? And you would simply look at 48,000 miles. You'd add up the values going this way, which would be 16%. And then there could be a follow-up kind of question saying they sell 275,000 tires. How many fail before 44,000? So you would find the percent that fail before 44,000. You'd look here and go down, that's 2.5%. So you'd take 0.025 times 275,000, and it's 6,875. Those were rather easy, weren't they? Yeah, I thought so.
Are we gonna have like the graph, that thing on the side?
The upper part, yes.
Oh.
Yes. All right. Here we go. All right, let's do this. How did your picture go?
Good.
Good. Where are they at?
I don't know. What do you mean? Oh,
Where did you have it taken?
the gym, the varsity gym.
Did you really go do that?
What? Yes, we went to it. I was confused where you were asking me.
Oh, okay. All right, here's a game. Here's a game of chance. Maybe it's a game for a charity that is allowed, or our state is talking about expanding gambling. Who knows? 3 coins. You're gonna flip them all at once. You're gonna flip them all at once. Heads, 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 you've got to pay $10. Let me try to make this clear. This is different from the problem that we had where you flip one and you keep going till you get to a tail. This is a different game. This game, I'll explain it again once I'm done here. I think I got it right. No, I didn't. Tails, heads, heads. There, I got it right, I think. This is different. The one we did was you flip a coin until you get a tails, you keep going until you get a tails. This one is different. This one, let me read the wording, you've got it in front of you. A charity game has potential. A person flips 3 coins. If they get heads, 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 they're paid something, et cetera, et cetera. All right, let's.
Do you have to pay anything prior?
This one we're not. This one I'm not gonna do it. There's gonna be another way too. This is gonna be another way. But this way. All right, the probability that you get heads, heads, heads. We've done this enough. This is stats class. Heads, heads, heads happens 1/8 of the time. Tails, tails, tails happens 1/8 of the time. Heads, heads, tails. 2 heads and a tail happens 3/8 of the time. And 2 tails and a head equals 3/8 of the time. On this one, you don't pay them or get paid until you do it. You don't pay them or get paid until you do it. So this you pay is going to be considered a negative. So I'm taking 10 times 1/8. And I get paying $1.25, so I'm going to put it as negative. You pay $1.25 is what you would expect to do. $5 times that is obviously, I'm going to actually, you'd get paid 62.5 cents. Here you get paid 37.5 cents. You know what I could do? I could do that. And here you get paid, well, duh, 75. Let's see if this would be a good deal for you. You're gonna lose $1.25, but you potentially are gonna gain 62.5, potentially gain 37.5, potentially gain 75 cents. You would expect every single time on this one to make 50 cents every time. If some charity is silly enough to do that, you should play it, because over the long run, you're gonna end up averaging winning 50 cents every time. However, you could get heads, heads, heads a few times in a row and lose your 30 bucks. Absolutely could, all right? But over the long run, you would expect to be getting that. And then, let's see, and then finally, do I have enough time?